Welcome to the presentation of OPC Xi as a tunneling solution. Xi tunneling solutions are implemented with a pair of Xi converters. The Xi converters communicate through WCF according to the OPC Xi specification. Xi can be configured to use any WCF supported communication protocols for either high performance or high security with data encryption and client-server authentication. Also, HTTP can be used for even simple configuration of connections through firewalls. The Xi tunneling solution has no vendor-specific interfaces. Components from different vendors can be mixed. Thanks to the standardized interfaces, tunneler modules can be eliminated when Xi application servers become available and replace OPC DA servers. The same is true for Xi clients. Xi clients can access the Xi converter server directly or can also directly access Xi application servers, completely eliminating DCOM. A stepwise transition from DCOM to Xi is made simple. Now let's look at the Advosol products that can be used for an Xi tunnel. The Xi Tocco Xi server converts from OPC Xi to OPC DA, HDA and alarm and events. For the demonstrated Xi tunnel, the Xi Tocco Xi server is configured for DA only. The client-side converter is an OPC DA server that converts one Xi server. The two converters combined build a tunnel for the OPC DA client to OPC DA server communication. Now let's look at the configuration of the Xi Tocco converter server. Usually Xi servers are distributed with the default configuration. For this demo, I have only the Xi Tocco executable in this folder and will create a new configuration to demonstrate the complete configuration of an Xi server. I use the Advosol Xi configuration utility to define the configuration. First, I create the bindings for a scenario with internet communication and medium security. This creates 4 bindings for TCP and HTTP transports, and for each transport a binding with and without security. The created bindings could be modified. The defaults are OK for this application, and I create endpoints with these bindings. For the selected medium security level, the created endpoints use secure bindings for the resource management contract and bindings without security for the other contracts. Now the server base address. The server needs to have a unique base address on this machine. I define it as Xi tunnel. For the TCP communication, a unique port number needs to be defined. For HTTP and HTTPS, the default port numbers can be used. In the app settings section of the configuration file are some basic definitions. I create the defaults. Now the Xi client interface is configured, and what's left to do is the definition of the OPC server that is to be converted. This is done in the wrapper server settings. I add a new server definition and enter the proc ID of the Matricon simulation server. And define a short name for this server. Credentials are not required. The OPC DA server is on the same machine. That's all that's needed for a complete configuration, and I save the configuration. And I start the server as a console application. It could also be started as a Windows service. Now we have the server-side converter configured and running, and we go to the client side. In this folder are the DA to XI converter server executables. I start the configuration utility and create a new application. Save it as the application configuration file, and we need to define the URL of the XI server that is to be accessed. We want to access the previously configured XI converter. Server access credentials are not required. The server is on the same machine, so we can test the server access to see if the definitions are correct, and we see its access is successful, so everything is fine. So now we need to register this DA converter server with DCOM, and I define the proc ID as DA tunnel. Save the configuration and register the OPC DA server. Now we have a registered OPC DA server, and I start the OPC DA test client. In the list of browsed OPC DA servers, we find DA tunnel and connect to it. In the item browse tree, we see the tree structure of the communicaiton simulation server. We browse into a branch and select one item, read its value and add it to a subscription. Do the same for a second item. Now we see data updated from the communicaiton OPC simulation server through the XI converters to the DA test client. To show not only a local access, I disconnect and change the configuration to a OPC Xi converter server on an internet web server. The URL is opcxi.info, and the server name, also an Xi Docker converter server that is configured for the communicaiton simulation server, is Xi to communicaiton. This remote server access requires credentials, username and a password. So let's check if this server access is successful, if the URL and credentials are correctly entered, and we see the access is successful. So I save this converter configuration and connect again to this converter server. Connecting to the converter server through the internet takes a little bit longer, and we are connected and see that this converter server is configured for DA and alarm and events. So we browse into the DA branch and also select an item, add it to refresh group, as I did before, a second item, and now we see the data updated through the internet connection. You can try yourself what I demonstrated today. On the advosol.com website, you find a lot of information about OPC Xi, a link to the converter servers I showed today, that's the DA to Xi converter, and the Xi Docker converter server. On the expressinterface.com website, you find a lot of additional information about Xi. For example, comparison of different OPC specification, benchmarks, free downloads of Xi utilities, and a list of internet accessible Xi servers.